Okay. Ooh. Alright, I know how to play this. I know. Oh, okay. There we go. Some repeaters. Lever. Actually, build it with white wool. Okay. Okay. Let's see if I can do this from memory. First off, let's do one lever there. Okay. I think I'm gonna have to pull up a basic schematic for this. Actually, you know what? Hold on. Let me just start laying stuff down. Okay. Oh no, that's an AND gate. Oops, nope. Definitely don't want that. Okay. That's an AND gate. So now let's figure out how to make an OR gate. Work our way from the back here. I don't know if this is going to be overcomplicating it, but we are going to try it. You know what, we might be able to just... No, that's not going to work. There we go. Let's get a sign. OR gate. AND gate. Okay. So now what we're going to need to set up, let's actually start off like right over here. Okay. Gonna be left, up, operand. Bit 1. Okay. This is right operand bit 1. Oh, whoa, nope. Okay. So I'm going to designate that as off. Because on a regular light switch, down is off. I never understood why Minecraft was like that. Okay. Start it off like that, keeping it in the off position. Okay, so if we're wanting to add these two together, if we've got 0 and 0, we need an output of 0. Right now we successfully have an output of 0. We have an output of 1. Oh, well, no, messed that phrasing up. If we turn one of these on, we should have an output of 1. Right now there is no output, so we technically don't have anything signifying this. But then what we also need to be careful for is if both inputs are 1, we need a way to turn this circuit off and branch out into another circuit. Because now this bit 1 on the output will be 0, but bit 2 is going to have a carryover. I don't know if I'm going to be able to do this from memory. Yeah, let me pull up the schematic of a half adder really quick. Half adder circuit. Okay, gotcha. So this has got to be an exclusive OR, but it also has to branch out into an AND gate. Okay, alright. Now how do we do an exclusive OR? XOR gate. So basically in an exclusive OR gate, if both inputs are 0, the output is 0. If either input is 1, the output is 1. If both inputs are 1, the output is 0. So it has to be exclusively either or. It cannot be both. It cannot be both in either position, if that makes sense. Okay. Let's start off like that. Oh, whoops. Okay. What is going to be the simplest exclusive OR gate that we can do? Okay. First off, oh no, that's not going to work. Well then, what we can do, throw that underneath right there. Okay. Oh, was that not a good position to place it? We actually can do it right there. That's fine. No, for the sake of simplicity, we're going to keep them apart. We're not going to try and have them run together. Okay. So this is where we're going to be doing our exclusive OR gate, and this is where we're going to be running our AND gate. So I guess simple stuff out of the way. Okay. Let's see, what is going to be the best way to do this? So both will need to be on. Not for right now. Let's go ahead and set both on. Okay, perfect. Now, in order for this to be on, let's throw that on right there. Throw that on right there. I don't think that's going to work. Definitely don't think that's going to work. Might actually have to just be down here. Yeah, it's going to have to be down there. Okay. And then uh-oh. That's no bueno. Awesome. Okay, so we got the AND gate. Not as pretty as we'd like it, but you know what? It's getting the job done. Okay. Now for the exclusive. Wait, are we doing exclusive OR? Yes, we are doing exclusive OR. Okay. Let's take a look here. And like that. Right? Bit of redstone right here. Put it right there. Remember, I did figure out a way to kind of simplify the circuit a bit. Okay, ground level. Rise up one. Then torch. And output. Okay, let's test that out. Nope, something's already broken. Okay, let's take a look. Oh, you know what? It's not that it's broken, it's just that it's not acting accordingly. Perfect. Okay. Yeah, I don't think there's going to be much of a way to simplify this. Now, in case anybody's actually watching this, let me go ahead and explain what's going on. So, let me see if I can do it on this. When you're adding binary, binary is basically you have either 0 or a 1. 0 false, 1 true. So 0 plus 0 is going to be equal to 0. 1, no, what are you doing? 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. And finally, 1 plus 1 is equal to 1, 0. So, oh, I already messed it up. There we go. So since the maximum capacity of this digit right here is 1, we would need to carry over. It's kind of like 9 plus 1 goes into 10, except it's not literally 10, it's just 1, 0. In other words, you're doing 1 plus 1 is equal to 2. 2 is represented by 1, 0. So, we have the left operand, bit 1, right operand, bit 1. Operand is basically like the number. So the left side number plus right side number is equal to blah, blah, blah. So this will be left and this will be right operands in this column here. When we do 0 plus 0, we're evidently going to get 0. Nothing plus nothing is still nothing. So that explains this logic right here. We're not getting anything at all. You know what, let me line up these outputs. Okay. Now if we do left side operand is 1, right side operand 0. Oh, got confused for a second. Left side operand 1. We have an output of 0. I'm sorry. Yeah, we have an output of 0, 1. I know that that's backwards, but because the way I'm setting this up is just backwards. Instead of going right to left to follow the operands, I'm going left to right. So, left operand 1 plus right operand 0 is equal to 0, 1, represented by this. Left operand 0 plus right operand 1, 0, 1, represented by this. Easy enough. Left operand 1 plus right operand 1 is equal to 1, 0. So remember, this is our first bit, which is going to be on the right. And this carryover is our second bit, this number on the left. So when both are flipped to on, the first bit should turn into 0. This second bit, or the carryover, will turn into 1. Perfect. Okay. Now at this point, if we want to start adding in a second bit, each operand having a total of 2 bits, as opposed to each operand having a total of 1 bits, we're going to need to use this carryover. Let's see if I can remember how it's used exactly. Okay. So I know we're going to need another half adder. Oh, that's right. We build another half adder for the second bit. And then we have to build another half adder for the sum of those second bits. Out here, we need to build a completely separate half adder that takes this carry out from the first bit. Oh man, I remember that. Jeez. Okay. Let's go ahead and separate this. Okay, so we're going to leave that here. Let's see how wide this got. Oops. Okay. So we had 1, 2, 3, 4, 5, 6, 7. 7 wide. I think that's pretty much going to be as low as we can get it. Yeah, without breaking physics and such. That's pretty much going to be. That I think. Might be wrong. Probably wrong. One, two, three, 4, 5, 6, 7. Okay. 1, 2. Okay. 2. Left operand bit 2. I am honestly thinking that I probably should have gone. Yeah, I think we're going to go ahead and flip it. That way it ends up correct. Yeah. Okay. Alright, alright. We're doing this. Right operand bit 1. Left operand bit 1. Okay, let's kind of grab what we've got from there, try and replicate it. Okay. Have this go out to the edge. There we go. Alright. Looking good so far. Okay, okay, okay. Come from down there. Okay, and it goes down like pretty much immediately. Right there, right? Yep, okay. There we go. Okay. Throw some redstone on over here. There. Oh, that's why. Okay. Whoops, wrong block. Oof. Excuse me. Okay, now we can get started on the AND gate. Damn it. No. There we go. Okay, so now we've pretty much got this facing the correct orientation. Let's make sure it works. Okay. Oh, nope, something's broken. Oh, gotcha. Okay, so far correct. That's correct. That's correct. That's correct. Awesome. Maybe I should add a repeater, just as a bit of a delay. Because we've got 1, 2, what is that, 2 ticks of delay? Oh no, I think just 1 extra tick. Okay, so basically these should turn on and off at the same time. Oh. Well, that didn't work as I expected. This needs to be delayed, doesn't it? No, that wasn't quite the answer. Well, let's try repeater right in there. Not solving any issues whatsoever. Okay. Why is it taking longer to go off? Oh well. You know what? We're just gonna have to live with that. Okay, so now we have it set up in the correct orientation. looks like we're going to need to scrap a lot of this. Okay. Oh no. Oh, that's gonna irk me. Damn it. Keep doing it. Okay, let's completely fill it back in. Okay. And basically we're going to need to replicate this whole thing. I feel like there's possibly an easier way to do this. No, I think in order to avoid crossing redstone, that's what we're going to need to do. Damn. Because if we drop it down here, we can't place a block over it. Because that's going to cut off both sides. Yeah, I think that's the best we got. Isn't there like a, yeah, daylight sensor? Okay, how does this work? Command block. What? Wait, really, how do you... I need to look this up, because I want to basically set it so that it automatically runs a command to set it back to daylight when it starts getting dark. Obtaining. Pick block control. Various commands. Okay. Give @player Minecraft command block. Okay. Give @player Minecraft / command block. Okay. Uh-oh. Definitely not what I wanted. Time set. time set 0. Okay, that works. Hold on. Where is kill all? Because I'm gonna make sure. Minecraft kill all mobs. Gotcha. Okay. See if we can paste that in there. Nice. Let's run it again. Awesome. Now we're back to square one. Okay. So now we don't ever have to worry about running the time set command again. That little sensor over there's got our back. Awesome. Okay, yeah. Now we need to replicate this, so bit 0, awesome. No, not bit 0, bit 1. I was thinking in my head whether I wanted to name it bit 0, but no. Okay. Well, let's get this one started. So, carry out. Bit 1 operation carry out. Bit 1 operation output. Basically signifying this is the output of our addition in the bit 1 of our adding, and this is the carry out of our operation on bit 1 for the adding, of course. Okay. Now we're basically going to replicate this. Bit 2. Oh wait, no. Left operand bit 2. Oh shit. Okay. Right operand bit 2. Left operand bit 2. Beautiful. Okay. Oh, wait, no. Okay, that is really going to annoy me. There we go. Just put it in the trash. There we go. Alright. Now we duplicate that. Oh, no, we go. Lay down all those torches. Awesome. Simple enough. Now, right? Yeah, like that. Awesome. Break left. And then it drops down. Uh-oh. Hold up. Oh, I'm just dumb. Okay. There we go. No. Oh man, I wish I had world edit for this. Definitely be a ton easier. Then, there we go. Let's lay down all the redstone and such. Oh, come on. Whoops. Reverse. Okay. Now this should work. Awesome. Okay. Now, we turn this carry out and this output into some more maths. Awesome. Yeah, we throw another half adder. Ooh, this will be fun. This is going to be really fun. Oh, I'll be right back. Oh, I am back. Orange, I don't know if you're still here. Whew, okay. Alright, let's see where I left off. Okay, that's right. Has it been? Yes, it's been set in the time. Awesome. Okay. Now we need to do a half adder over here. Oh, damn it. Still not here. Wait. God damn it. Okay, well, I guess, I should explain what's going on, shouldn't I? Excuse me. Okay, well, are you familiar with Minecraft? And if you are you familiar with redstone? Okay. So arithmetic logic unit is a part of a computer processor unit, CPU. It's in charge of taking a set of bits as a left operand and a set of bits on the right operand and adding them together, and the output is the addition of both operands. So basically, left operand 0 plus right operand 0 is equal to 0, 0. Left operand 1 plus right operand 0 is equal to 0, 1. Left operand 0 plus right operand 1 is equal to 0, 1. While left operand 1 plus right operand 1 is equal to 1, 0. This is binary. So both input 0, output 0. Either input 1, output is 0, 1. Both inputs 1, output is 1, 0. This is the equivalent of 2 in decimal. So what we're doing is we're putting all that together. So if we turn this one on, we have an output of 0, 1. If we turn that on, we have an output of 0, 1. If we turn both on, we have an output of 1, 0. This is the carry out. And the reason why we're doing a carry out is because now we have operand 2. So it's basically going to be like 0, 0 plus 0, 0 equals 0, 0, 0. Then 0, 1 plus 0, 0, blah, 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 blah. But then it's also going to be 1, 0 plus 0, 1 equals 1, 0, 0 kind of deal. Basically, we're adding another digit. Long story short. So, all of this redstone is getting that done. What you see in this block here is the equivalent to what's in this block here. But now, in order to form the two together, we actually do need to do another one of these blocks. But instead of the inputs being these two or these two, we need the inputs to be this as, let's say, the left operand, and this as the right operand. And we carry that output out as this output, and then we, right? Do we test it to see if it overflows, thus carrying out? I think it will. Okay. But yeah, science. Okay. Let's get rid of that. Let's get rid of that. Go ahead and bring these two together. Automatic shoe dispenser was impressed with this guy. A bit. It's a bit. Okay. If you're familiar with logic gates, basically we're doing exclusive OR as our just regular output, and then we're also doing an AND gate over here as our carryout. Doing the exclusive OR because we want, how do I do this? Okay, now this is going to be the logic table. This is not going to be actual addition. So 0 plus 0 is equal to, actually, there's a better way of representing it, I believe. False plus false is equal to false. So both outputs off will equal, both inputs off will equal output off. True plus false will equal true. Left input on plus right input off will equal output off, if I'm saying that correctly. Left input off, or left input false plus right input true is equal to output true. And left input true plus right input true is equal to output false. That is our exclusive OR logic gate. Because basically, we want to make sure that this right digit in the addition table, that's basically going to line up with this. Because if both of these are ones, we don't want anything in this right side here, because now we're carrying it over. It's like 9 plus 1 equals 10, except that's not legitimately the math here, but in decimal, that's the equivalent of 9 plus 1 is equal to 10. You don't have anything in that first digit. It carries over into the second digit. That's basically what's going on here. Long story short. So oh, hold on, something's broken. Oh, gotcha. Okay, hold on. Does this work? It does not. Well then. Oh, that breaks it. That's great. Uh-oh. Okay. So the 0 on the other side is more of a placeholder. On this sign? Oh, I hate how you can't edit signs. It's so annoying. Yeah, that middle one. Middle one. Okay. Hold on. So the 0 on the other side is more. Yeah, that middle one. Okay, no, I've lost you. I don't know what you're talking about. But oh no, you're saying the middle sign. Okay, so the 0 on the other side is more of a placeholder. If you're talking about the 0 that ends up in this right column, in this first digit, yes and no. It's still representative of data, but basically, okay, so I do these switches opposite. Let me actually set this back up the way it was before. I do these switches opposite. Down is equal to false or off, because in the real world, that's how light switches work. But that's besides the point. So, with that being said, we turn. Okay, hold on. So this is the equivalent of 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 1 is equal to 1, 0. So while it is technically a placeholder, it's just sitting there saying, hey, there's nothing here. it's still representative of data. So, I believe that answers your question. Believe. But now, we need to basically do this whole block right around here and basically add this and this. This is the carryout output of the first operand, or the first digit. This is the regular output of the second digit. So, now we've got these bad boys lined up like that. Let's actually bring it up a level. Now we need to do... Okay, so we need to do an exclusive OR gate, which is this top side of things, not this right side and bottom. We need to do this top side. So, I'm just trying to think if logically that does actually make sense. So if we're doing both of these are ones, then we need to carry it over to here. So then something's already broken on this side. Oh, no, it's not. It's just not going to that thing right there. Okay. So as long as we can see that redstone on, that's basically this side being on. I'm going to play devil's advocate here. Can something abstract like this make some sort of function in Minecraft itself? Or is this some sort of project in particular that you need to focus on? This makes some sort of function in Minecraft. In a way, it can make a function of Minecraft. I mean, I don't know if you've seen videos of it before, but this is basically the start of how people make computers within Minecraft. And it's not like computer, like have a mouse and a keyboard and you can browse the internet and stuff like that. It's very basic, rudimentary way of basically performing math on numbers. But those numbers are representative as binary, and it can of course be converted to decimal, which is what we understand mostly. So is this some sort of project I'm partaking in that you need to focus on? In a way, it's not that like I'm doing this to just completely focus on it. I just so happen to be streaming it. I also don't mind interacting with people and answering questions like what you're doing. Like you're asking some questions, and I like to try and explain how this stuff works and why a computer runs off of this kind of stuff. But yeah, basically in your processor, can you imagine just billions upon billions upon billions of these little things that perform little tiny logic, and that's how you get Minecraft on your TV screen and how you can browse the internet? Yeah, that's the power of logic gates, transistors. Okay. So, let's see. With more simple stuff like combination locks, automated storage, furnaces, not so much computers. Alright, just make sure I wasn't too much of a... No, you're fine, you're fine. Okay. So, basically the dilemma that I'm having right now is part of the logic. So, if we do 1 plus 1, we're definitely going to get 1, 0 as our output. So that's where the carryout comes in. But the carryout isn't an actual output. It's just saying we didn't have enough data to hold that information in here, so now we need to send it off into the next digit. Basically the equivalent of doing 9 plus 1. The single digit of 9 doesn't have enough capacity to represent 10, so that's why you create that second digit. Thus, you get 10. So that is what I'm trying to figure out how to do with this here. So if we do 1 0 plus 1 0, that is then going to equal 1 0 0. So if this were the case, we would need to form a connection between the carryout of this pending half adder. Oh yeah, and these blocks are called half adders. And then in a second, we're about to complete an additional half adder, which would then make one full adder. So we're going to need the output of this third half adder to somehow connect to this output. Hold on, I'm not phrasing that correctly. The carryout output of this third half adder will need to be connected to this carryout output of the half adder for the second operands, for the second bits. Goodness gracious. Try saying that 10 times fast. Okay. Are we going to need to carry out... No, are we going to need to extend an AND gate? No, because that's what this half adder is for, right? I think so. Okay, well, you know what? Let's get building. And if we need to make any adjustments, we'll make some adjustments. Okay. So we're going to copy that exclusive OR gate. Okay. There we go. Just like that, we've got an exclusive OR gate. Now let's see. Okay, we are actually going to need to extend out. Not the element of this, but maybe put them all in a off position and then test it as you go along, revising as you need to get that output. Yeah, that is a good idea. Okay, so far, this is correct. So we're good there. Throw on this one. 0, 1. Awesome. So this is 0 plus 1, or, I'm sorry, 1 plus 0 equals 1. Okay. Now, 1 plus 1 is equal to 1, 0. Perfect. Okay. Alright, so let me get to labeling. First, nope, bit 1, output. Awesome. Now this is bit 2, output. Now that we've got that set up, that's correct. Now we have 1 0 plus 1 0. Okay, so from here, this is technically correct, but we need something to represent 100. Yeah, we're gonna need something to represent 100. Oddly enough, what works is if we throw these both on, but this isn't correct. Oh, and granted, it's a lot more simplistic as it just connects to machines and sensors, plus any other jargon I'm forgetting. Yeah, no, I noticed that they have like all those gates and such, and I don't know, I'm already having a hard enough time with O and I as it is, without all that stuff. Okay. Excuse me. So now what we need here is... Oh, then don't play the new beta they added. Although there are hats. Oh, I didn't even know they had a beta right now. Beta, whatever. Okay. So this is technically true, but it's also not correct because we need to represent the carryout of this half adder, which will require an AND gate. Wait a second. Can we do that? Wait, really? Hold on. Beta. What? Beta? Beta. Okay, okay, yeah. Beta? What are you trying to say? Okay. I think I might have actually figured out a way to completely simplify this. Okay. Okay, okay. Alright, alright. So, let's set this up. Oh man, I am onto something. So, got that. Okay. Wait, I'm not doing this correctly. Yes, I am. Okay. Acquired. Oh my goodness, I hate you. Acquired. Ugh. So annoying. Okay. Then, boom, boom. Boom. Oh, wait. Now let's test this. Great. Great. Awesome. Okay. So now, I think I might have figured a way to represent the AND gate within this. Hold on. I need to think here. Okay, hold on. Oh, wait. I don't think that'll actually... Wait. I think this is it. Make sure it stays off. Awesome. And then... this redstone should turn on, which will then turn this on. Oh, nope. Excuse me. Shit, okay. So that completely breaks everything. Damn. I thought I was onto something. Oh, nope, that was bad. That was bad. Wait, what? Man, I'm really trying to... I thought I was onto something. I thought that I could shorten it up, like this whole half adder. Okay. Maybe. Oh, wait, no, we want to go this way. Oh, whoa. Nope, that's not going to work. Come out one more. Oh. Okay. All I know is where the signal is outletting from. Could you add a redstone repeater to increase delay? It could. It could. But with this, it's going to be all about speed. Okay. All right. Hold on. I might be onto something. Okay. Let me test it out. Bring it in from... No, what are you doing? Oh my god. Stop it. Will it reach? Okay. So... Oh, wait a second. We need to inverse the... Okay. Okay. It will work. Not what I wanted, game, and you know that. Awesome. All right. There we go. All right, so basically, within the exclusive OR gate, we had an AND gate that we could just draw the signal from whenever both inputs are 1. All we had to do was inverse it, because it was already inverted. And voila! So this is the first digit, this is the second digit. 0 plus 0 is 0, 0. 1 plus 0 is 0, 1. 0 plus 1 is 0, 1. 1 plus 1 is 1, 0. Awesome. Okay. So we went from 7 wide to 5 wide. And pretty much the same length. If not shorter. Oh yeah, it can be shorter. Okay. Acquired. God damn it. You know what? I think we'll start building it from here since we already have this set up. Okay. There we go. Keep up the good work. Over to YouTube. Okay, hold on, Rammer. I gotta know if you're real. Say any other kind of message in the chat to know if you're real. Because I've came across spam sometimes. Donate $1 and I'll give you a special shout out on one of my videos. Must put new videos that you send $1. Yeah, I don't know. That sounds kind of scammy to me. Okay. So far this is definitely a lot easier on the eyes. And less redstone and logic to deal with. So that's always a plus. Okay. Oh, whoops. Wrong spot. This goes up. I am actually going to go ahead and stop streaming for probably for the day, but at least for a little bit. This is where we're gonna leave off. Let me actually leave a sign for myself because I'll forget. Skinnier half adder. Okay. All right. Yeah, I'm out of here. Take it easy, Orange. Thanks for always tuning in. I appreciate it, man. You have a good day with your thing. Yeah, whenever I get back to working on it, I'll throw the stream back on. But yeah, you take it easy. Have a good day.